Hello, everyone. It's my distinct pleasure to be here with you. Thank you so much, Senator Daines, for your great vision, leadership of this summit. Thank you, President Casado and Montana State, for hosting the Montana High Tech Jobs Summit. This is critical. I'm so glad to be here. Frankly, it's just great to be home in Montana. I've been gone a long time, but home is always home, and it's always great to come back. And first, I'll start off with the great ambassador of exploration, Nichelle Nichols, who played Lieutenant Uyara on Star Trek, for all you Trekkies. She also helped recruit many of NASA's earliest astronauts of color, famously said, "Science isn't a boys' game, and it's not a girls' game. It's everyone's game. It's about where we are and where we're going." So for me, it invokes Gauguin. Where are we from? Where are we in the present, and where are we going? I actually used that Gauguin masterpiece when I taught at MIT for my technology and policy program in leadership development, to reflect on where we've been, where we are. We're right here at MSU. I couldn't be happier, and where we're going, and the sky's the limit. As a rocket scientist, I get to say things like that and dream big, and really it's just have a lot of fun. I mean, in the passion and the things we do, that's what really take us there. So glad to be here. It's a great adventure and really fueled by technology and innovation. At NASA, we believe very strongly in Montana and really think that it should be a world-class emerging high-tech hub. It's great to go after this panelist just to already see what's happening, but again, to ask what can be in the future. I know I'm standing right here in the technology corridor, but it's for all Montanans and across, hopefully, the entire Big Sky country. At NASA, we invest more than $8 million a year in Montana, mostly in education, teachers, universities, educators. I'm from a family of teachers. Matter of fact, we just heard about Western Montana College, the teacher college. That's where my folks went and got their teaching certificate, so it's very nice to meet the chancellor. My little brother, he's not so little anymore, he's a teacher of art in Butte Elementary, and before that he was at Boulder for his first job teaching. And so here, growing up in Helena, I am a rocket scientist, engineer. Don't you think this is what a rocket scientist should look like? I do. And well, I was 5 years old during Apollo, watching it from our den. We kind of had a little scratchy TV. It was, that long ago. But it really inspired me. And today, I actually work with Buzz Aldrin, and we calculate orbital mechanics to Mars. Spiraling orbits seem to make the most sense if you want to think about that. And so I just learned to dream really big in Big Sky country. So that was my 5-year-old lesson. And again, I think growing up in my family and among teachers and the public school system here, and nature was a really big teacher for me. Inspiration, place to think, to dream. As an engineer, I think all I'm doing is really, I'm just trying to, kind of copy nature, because every time I look, something has already been fantastic in design, and I think, how can I do that? As an engineer, I'm a designer, a maker, and maybe I can just do that. Hence, you've heard a little bit about the biosuit. Well, if I could just copy the skin's function, maybe I could have a breakthrough in technology. So in my career in teaching and education, research, leadership, and exploration probably started right here in the mountains of Montana, exploring just what that next little bug was, or ducking from the bats coming out of the cave, and probably my fascination with flight as well, just looking up and looking down, looking at movement. So as the Apollo professor at MIT before I joined NASA, I was working on 4 different suits, always thinking about what's the breakthrough technology. I would give the students the challenge to think 10 years in advance. What could it be? And then I'd say, what about 40 years in advance? We didn't really ever answer that question. And if we did, we would have probably really gotten it wrong. I know that much to say that. But not to think next year, and then next year. And so we have to think about budgets, but to think about a decade and a decade. And that's what we're planning for. Again, all of my work, of course, is in space, but it's exploration for me via Earth, the sea, and space. I'm also a big sailor and have sailed around the world on our sailboat, exploring Earth, teaching kids, And what did we teach? Well, we talked about exploration via sea and space, because every little island kid that I know knows about isolated, confined environments. That's probably lost someone, one of their family members, trying to survive, trying to fish and explore. So they really know about extreme environments and living in survival. So that teaches us all, and trying to make that connection across exploration, again, from sea all the way to space. It's quite a privilege, as you might imagine, to be able to train and work with astronauts and study. I'm fascinated with how they move and how they perform. And for me, again, growing up in Montana as an athlete, and I was pretty good at math and science, but I was much more interested in basketball and ski racing. And I grew up in Helena. My favorite ski area still in the entire world, Bridger Bowl, I have to say. I'm just saying, I haven't been back in 30 years, but I will get back to ski at Bridger Bowl. That's where I went and raced most weekends in my high school, trying to train for the Junior Olympics. And I didn't make it, but a really great guy from Bozeman did make the Olympic team. And so again, we learned a lot, the challenges, the teamwork. I think sports really taught me a lot, again, and just anything is possible. So back to my astronauts now. Fascinated with keeping them alive and healthy and safe. And we're going places now that we've never been before, with people and definitely with all of our science missions. A shout out to New Horizons, right? The Pluto mission. I hope you were all there with us in June, kind of Pluto mania. NASA's now been throughout the entire solar system. I still count dwarf planets. I was kind of a dwarf basketball player, so I count everyone. And we're learning so much more. We're learning there's kind of these mountainous, ice mountains on Pluto. Who would have known? We didn't know because we couldn't see. We could think about it. We dreamt about being there, but now we're there. We can actually see it. So, dream it, believe it, and then let's go there and really do it so that we can see it. So our astronauts are now on the International Space Station, as you might know, NASA's lead. There were 9 astronauts last week. It doesn't happen very often. That means hello, we're back. We are back in business. We're there. We're here to stay. We are studying. We're really preparing for our journey to Mars. This is the first step in our journey to Mars. The 9 astronauts said 3 went up for a short duration mission, 10 days overall. And I was over in Europe meeting with the European space agencies and the new leader of the German agency and the French agency, and then all of Europe, the European Space Agency, because they were flying technology. It has a lot to do with technology. It's a patent. We have the patent on a suit called the gravity loading countermeasure suit. It's a lot of names for the skin suit. What that is an exercise suit. Because did you know when astronauts go in space, you lose about 30% muscle mass, about 40% strength loss. But that's the good news. About 1 to 2% bone mineral density loss per month. All right, now who's signing up for my Mars mission? That's what I said. Usually, I heard there was students in the audience, and they raised their hands. So, all right, thank you. But we're not going to go with those kind of losses. We call those countermeasures. So that's what we're doing up on Space Station. We're countering that. We don't see nearly that significant of bone loss today because we're exercising. There's pharmaceuticals. There's all kinds of things that we can do. I kind of look more to the radical technology side of things. Well, what if we give them this, elastic, bungee suit? And the Europeans took that and flew it on their Danish astronaut, Andreas Mogensen. And how about comfort and fit? Is this something you could do in parallel with exercise, a compression suit? That worked out pretty well. 3 of the crew landed safely yesterday. I'm glad to. So now there's 6. And we have Scott Kelly, the American astronaut Scott Kelly, who's on his year-long mission. It's phenomenal. And he has a Russian counterpart on the year-long mission. They're doing science, they're doing earth science, they're looking down to Earth, we're looking out, just amazing amount of science. Of course, a lot of human, experiments as well. And the first time we can really do genomics on a human, because Scott has a twin brother, Mark, that you might have heard of. So we can test the twin on Earth, as well as Scott being in space in the microgravity environment for a year. So just incredible things to do. Bring it a little bit closer to home here, analogs. We don't get to Mars too often. We don't get back to the moon for a while, right? We're trying to get there, but Montana and Idaho, there's some parts that are kind of Mars-like, I'm here to tell you. So there's a great experiment. So with outreach with some Montana folks are participating, and in Idaho, in the craters of the moon, Good name, actually, for those lava tubes, I have to say. Well, that is kind of, and we can look at volcanics, we can look at the craters. So we go there in field studies, and it's about education and training the next generation, but these are the world's best scientists, coming to look, to discover, learn about Earth, and that teaches us about, of course, the planets. So in terms of NASA, and I guess I'm no longer a new senator. Since it's been over 3 to 4 months now, the honeymoon's over, and now it's all my fault, or responsibility, we'll say. So my portfolio is wonderful. I'm looking at exploration and Journey to Mars. I'll tell you a little bit more about that. Specifically, technology and innovation. That's why it's such a pleasure to talk to you and be here and really just to support you in all the great work that you're doing, as well as education. So who could have a better portfolio than technology, innovation, education, and outreach? So here, telling you a little bit more about how I'm going about that. First, a little bit of data, and then that'll propel us into thinking about the future. I've just read a recent Georgetown University study suggesting that the jobs in science, technology, engineering, math, STEM, they'll grow by 26% by 2020. So they're going to grow by, over 25% just in the next 5 years. A little food for thought. The U.S. Department of Commerce study found that the average jobs, these STEM jobs, they're paying 26% more than average. And I've heard some numbers here from Montana that even surpass that. So I'd like to challenge you all, and I'm definitely on board, of course, with all of STEM activities, but I've changed it. So let's see what you think of this. To STEAMed. You're probably familiar maybe with STEAM. People say, put the arts in, because all I know is I need everyone. I need every little boy and every little girl out there. I need them all. So I'm not exclusive, and I'm changing the conversation. I'm not saying, do you have to be the best in your math class or physics class? I wasn't. You have to be proficient, and you know what? Those are the foundations of a great engineering education, but you like to make stuff, you like to design stuff, you want to build and do things like that. So I'm calling it STEAMed now. Personally, I'm all on board with STEM education, but I can put in the arts because I have room for everybody, and D is for design. Because then we get everyone. This whole new generation of makers is cropping up, and they might not see themselves as a scientist or as a mathematician, and that's great. Again, I'm here to say we need all of you, and so for me it's science, technology, engineering, arts, math, and design to help propel the leadership in the U.S. In space, of course, but even more importantly, leadership, competitiveness, and innovation here on Earth. NASA's Journey to Mars, I have to tell you a little bit more about, because I'm just too excited so I'd love to talk about it and recruit all of you to join us. Some of you are already participating, thank you. We actually have a very clear vision to get to Mars. We need scientists, engineers, managers, entrepreneurs, fashion designers, physicians. We actually began our exploration of Mars over 4 decades ago, first studying the red planet. Today we have 5 orbiters and rovers on Mars. I get daily updates. There was a great news today about some new rock dust stratification. The geologists will have to explain it to me, but it looks like some similar patterns that we know about on Earth. So again, every day we're getting new HD photos. We're studying. Where was the water? Could it sustain life? Could there have been life, 4.3 billion years ago? And keep all of that in mind. And again, back to International Space Station. NASA's Journey to Mars starts at International Space Station, as I said, and beyond for the last decades. So this is audience participation time. So I have to ask, how many of you have read the recent May paper in Physical Review Letters entitled Precision Measurement of the Proton Flux in Primary Cosmic Rays and Rigidity from 1 gigavolts to 1.8 teravolts with the Alpha Magnetic Spectrometer on the International Space Station? Yes, please, yes, yes for high energy physics, yes. See, the rest of you have a little bit of homework to do. But that's by Nobel laureate Sam Ting and his group. And the reason I bring it up is the best example I have of interdisciplinary. This is a little United Nations of the world's best physicists. They're all the authors on this paper. This is just our most recent paper that I'm still trying to get through. I'm kind of stuck at that 1.8 teravolt. But it's high energy physics. Why is it so important? It's important because he's rewriting physics. So Sam will tell you that for his experiment on International Space Station, the Alpha Magnetic Spectrometer, what they've done on Space Station with their research is equivalent, it's more, it's surpassed the last 100 years of physics research and high energy physics for all the world's physicists. So, you know, that's return on investment. Ask me about return on investment, you know. I can't give you a better example than return on investment than that. We had to be patient. You know, we had to wait. Didn't happen as quickly as maybe you'd like to, but that's serious return on investment. You know, that's the world's physicists with breakthrough. We're gonna have to rewrite all those physics books. Sorry about that. Throw away the, good thing we're in ebooks now. Okay, so from International Space Station on our journey to Mars, we move beyond. We go beyond low Earth orbit. We go into cislunar space. That's just Earth-Moon orbit. I've just had the chance to come back from our facilities down south in Huntsville, Alabama, and Stennis Center in Mississippi, as well as our Michoud facility in New Orleans. And it's not on paper. This is not a paper design. This is called the Space Launch System, or SLS. It's our heavy lift launch vehicle, and they are building and welding. Matter of fact, I saw the coolest, biggest, huge, enormous welding machine I'd ever seen. Not very many people around. There's a lot of jobs created, but these things are going up because of all this automation, and it's huge. SLS wouldn't fit, you know, even horizontal in this room. Fantastic. So that's our heavy lift launch vehicle. We're making incredible progress on Orion. That's the crew capsule that goes on top. And again, just seeing all the crews come together, it's government funded, of course, it's a huge amount of industry, workforce, and they're all doing their best. We just heard about excellence. They are at the top of their game, they are at the top of the world, and they're gonna get us, you know, on our next journey beyond station into cislunar space. So many, many ways, I think we're kind of at a teachable moment when it comes to Mars and exploration. Movies like The Martian just opened up Friday at the Toronto Film Festival, it's going to open up October 2nd, but so all month, and next week's, that's what I get to talk about, is The Martian. Now, as an engineer, I used to kind of be a little bit, I guess, snobbish about the physics, and they didn't get the physics right, and a little critical of space movies, I have to say. I've changed my mind. First, this one's great, and second, they got most of the physics right, and it gives us at NASA a chance to say, guess what, here's your investment. Here's the 9 technologies that we're working on. So we've worked with the folks that are producing the Martian to have a win-win, basically, for outreach, and you know, space is the coolest thing going, at least in my world, and again, all the benefits here. So in the journey of Martian, we're celebrating technologies. Just give you a little preview, because again, I just can't help talking about them. They're so fantastic. It comes to energy. We do have, you know, ion propulsion. We also have I can't even say this, radioisotope thermoelectric generators, RTGs for short. For ion propulsion, you don't send humans on ion propulsion. This is slow and steady. This is like how you win the race, right? Slow and steady. You just keep going slow. It actually gets pretty high speeds with ion. You can get to over 200,000 miles per hour. I like speed as an aerospace engineer. But you go out slow and you keep accelerating, so you get faster and faster and faster with ion propulsion. We're demonstrating that now. That is critical energy for the future. The RTGs have flown with us on most of our spacecraft during Apollo, and then Mars Curiosity rover, and our upcoming Mars 2020. They're essentially, RTGs are essentially space batteries, if you will. So again, we need to invest in these technologies. We need to prove them. The ion propulsions, we're really looking to do that for in-space propulsion. And when it comes to air, just simple life support systems. NASA already has an oxygen generation system on International Space Station, but we have to close the loops. We have to close the air loop, but we have to close the water loop. We can't quite do that right now. So in the cislunar space, we call that the proving ground. It's kind of phase 2. That's the 2020s. The 2030s are when we finally really get humans to Mars. But we have to prove out all these technologies. It's all about the technology investments, proving. My sailing analogy is, you know, from space station, we're minutes and hours away, you know, in your sailboat, right? We get to cislunar, the proving ground in the 2020s. Now we're days to a week of help. As a circumnavigator, we got out in the middle of the Pacific. We were days to a week when we lost our steering. We kind of called it our Apollo 13, our hydraulic. I'll tell you about that story if you have a question later. We survived. I came back. I have a great job now. And you get to the 2030s, our journey to Mars, and this is where we're Earth independent. You have to be completely Earth independent. All of the systems need to be Earth independent. And food, not to save it for last, but for food, you know, space food is just okay. But we have kind of a new wonderful breakthrough. Maybe you've seen it. It has a lot of tweets, a lot of hits. The veggie experiment on station. We're growing lettuce. We're growing new things. People kind of around the world love it. It's great. But you know, that's biological life support systems. What can we produce, again, in all of these closed life support systems? Reclaiming all the water. You gotta close the water loops. So yes, we do recycle your urine, all your bath water, and everything you use to brush your teeth. You know, very efficient. We have to be able to recycle all these systems and use the water and the food. So taken together, what all this means basically is that we need more high-tech jobs, we need more high-tech jobs in Montana, and we need all of you. NASA's, if you remember one thing from my talk, is that NASA needs all of you and all of the folks that you're gonna teach and inspire and all the next generation to bring along. And so thank you for bringing us all together today. This summit is really critical. Specifically, in my opinion, let's identify the knowledge gaps, you know, the skills gaps that we'd like to work on to better collaborate from government, industry, and academia. I think that triad is so critically important. And those partnerships are hard. We need to look to innovative partnerships. We're trying to do that at NASA. Again, times get hard. You get very innovative. And that triad, again, the government, the industry, and academia, and really showcasing the high-tech community and the opportunities it presents for great jobs, great technological advancements, new discoveries, improved quality of life, really across the globe. And you're all the ones who are making it real. And I'll leave you with one kind of vision, kind of a reflection. I usually invoke a spaceship Earth. You know, you look back at, from the Apollo 8 mission, that vision of Earth, that kind of changed humanity, changed our mindsets. I still use it as a screensaver until last week. We gave you a new image, and it's from our Discover satellite, and it's out at L1, the Lagrangian point. Looked back, and the moon was transiting Earth, so that's my new screensaver. But you know, the vision from Buckminster Fuller that this is spaceship Earth. We're all on it together. It's very fragile. It's a very fragile oasis. It's a beautiful planet, and just kind of that vision to always kind of reflect back on Earth. And one of my heroes, Amelia Earhart, once said, "Never do things others can and will do if there are things others cannot or will not do." So I think that's what we're here today, and thanks for everyone for making this high-tech job summit possible for the very first time, but I think for a very long time to come. And I can't wait to see what happens next, and thank you so much. I think I left time for questions. I have questions, and I have a video, but I'd rather take questions. You know, I don't know how are we doing on timing, but it'd be great to do open
question.
ones.
We get the. Let's do it. Go for it. Any questions for Dr. Newman? Got one over here.
Okay.
Good morning, Dr. Newman. My name is Diane McClellan, and I'm the president of Astra STEAM Summit. And I want to address your comment about the need for getting more young people from the next generation involved in STEAM and STEM. We launched our project in Sunnyvale, California last year on the campus of Microsoft. And I want to thank your team at your Ames Research that participated not only last year, but this year. So we've had 29 girls go through this program. And the good news is we created a template program called Astra STEAM in a Box, and we want to bring it to Bozeman next year.
Excellent. Well, great. Thank you for your good work. And absolutely, I'm sure Bozeman, and bring it through on a traveling show throughout the entire state of Montana so that the kids here can get exposure to that as well.
Thank you. It's all geared on having young girls come for a day and a half with the idea that they'll be part of a team that comes up with a business concept and an app, and they pitch it to a mini Shark Tank panel and can earn tens of thousands of dollars in scholarships. So we think this is
good incentive.
Yes, so we want to bring it here to Montana. So thank you for your
Excellent.
support.
Absolutely. I'll continue to support it as well, to get those incentives, especially for those fellowships in our fields. Yeah, so I think everyone probably heard the question, or the comment to comment on was, how can we all be involved? And these hands-on experiences, again, that's why I go back to my analogy, you know, field studies. Right? There's a lot of academics we can do and things like that, but giving the students the opportunity to come into your labs, please, and I'm sure we all do, is that for all the academics in the room and the industry folks, it's kind of take your child to work day, but we need to take all the children to work and in the high-tech jobs and arenas. So, please bring them into your laboratories, bring them to work with you, and they need to learn it all. Again, I'm a huge proponent of, multidisciplinary. I don't get stuck in any discipline because all I know is the challenges and issues we have are so large that we really do have to cross the disciplinary boundaries, and no better place to show that to kids and students when they're thinking about what can I be when I grow up, and just a day in the life of all of us in our work. They would just see that firsthand, and it's great. Maybe you have a little 3D maker. Let them, in a matter of 5 minutes, they can put a little design in there and make it like a 3D print. And so just giving them that opportunity. So again, thanks for the comment. And absolutely, it's incumbent upon all of us to do as much as we can. And then next year we'll come back and see how we've done and look at the metrics. And hopefully we have a lot to be proud of. So thank you again for your attention and time. It's my pleasure to be back home in Montana, to be with all of you, and go forth. And I look forward to joining you on your journey here in high techs, as well as you guys joining us to Mars.